So any doubt in this one bit comparator? So ಅರ್ಥ ಆಗಿದೆಯಾ?
Yes, sir.
ಸೊ ಒನ್ ಬಿಟ್ ಕಂಪಾರೇಟರ್ ಅಂತ ಹೇಳಿದ್ರೆ ಈ ಎ ಮತ್ತು ಬಿ ಏನಿದೆಯೋ ಸೊ ಅದರದ್ದು ಬಿಟ್ ಲೆಂತ್ ಒಂದು ಸಿಂಗಲ್ ಬಿಟ್ ಆಗಿರುತ್ತೆ. ಸೊ ದಿಸ್ ಎ ಆ್ಯಂಡ್ ಬಿ ಕ್ಯಾನ್ ಬಿ ಎನಿ ಬಿಟ್ ಲೆಂತ್. ಸೊ ಇನ್ ಜನರಲ್ ಆಗಿ ಎನ್ ಬಿಟ್ ಅಂತೀವಿ, ಬಟ್ ಇಲ್ಲಿ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎನ್ ಈಸ್ 1. Okay, so the next one what we have is to discuss about 2-bit comparator. So 2-bit magnitude comparator ಅಂತ ಬಂದಾಗ ಸೊ ಲಾಸ್ಟ್ ಕೇಸಲ್ಲಿ ಏನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ನಾವು 1 ಬಿಟ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೇವೆ. ಅಂದರೆ ಎ ಈಸ್ ಸಿಂಗಲ್ ಬಿಟ್ ಆ್ಯಂಡ್ ಬಿ ಈಸ್ ಆಲ್ಸೋ ಸಿಂಗಲ್ ಬಿಟ್. ಬಟ್ ನಾವು ವಿಲ್ ಬಿ ಕನ್ಸಿಡರಿಂಗ್ 2 bits of A value and 2 bits of B value. So that's why 2-bit magnitude comparator ಅಂತ ಬರುತ್ತೆ. So once we have the 2-bit magnitude comparator, so here as you can see this the 2-bit values. So I have not represented it as just A and B. So I am representing the 2 bits as the bit 0 position and bit 1 position. So similarly for B input, bit 0 and bit 1 position value. Okay, so usually we represent this slash notation to represent this single. This is not a single line, it is a multiple line, and how many number of lines we have there is 2 lines. So that is A0 and A1. So suppose for example in simple diagrams this is fine. So suppose if you have a 10 number of input lines, then you need to write 10 lines. So instead of that writing 10 lines, you can write one line input and you can slash that particular line and you can represent the number of lines by a numerical value. So this slash with a numerical value represents how many number of input lines are there in this. Okay, so we have 2 input lines over the A input section, and similarly we have 2 bits over the B input part. So now, so we need to compare the magnitude of these 2 bits and we need to establish the relationship between those two 2-bit values. So as we have seen in the 1-bit comparator, the same outputs, that is A greater than B, A equal to B and A less than B. So since we have two bits, so we are going to have 16 different input combinations. So that is 2 power 4. So we are going to have 16 different combinations. So the 16 inputs to table here it is shown. So for every 4 rows we have separated, because I'm keeping the A1 and A0 value constant, that is 0 0, and I'm varying the values of B0 and B1, that is 0 0 0 1 1 0 1. Likewise again I'm changing the value to of A input to 0 and 1. So again B value varying from 0 0 0 1 1 0 1. So again change the value of A to 1 0, B value 0 0 0 1 1 0 1 1. So similarly A value to 1 1. So that means we are checking all each and every possibility out of that 16 combinations. At the output side, if you see, we have 3 columns of each 1-bit wide. So one is A greater than B, one is A equal to B, and one is A less than B. So first note down this two table. So how we are going to fill this output columns? So that we will look now. So I have taken only the first 4 combinations. So here what I have 0 to 3. So these first 4 combinations. And later on we will use the same logic to fill out the remaining part. So first I will be considering this first 4 input combinations. Okay. So now if I look at the first 4 input combinations, the value of A1 and A0. So the value of A1 and A0 is 0 0. Similarly B1 and B0 is also 0 0. So now we are considering the magnitude. So magnitude in the sense, now I will be taking this whole thing as a single value and again this whole thing as a single value. In the sense, the 2 bits will be converted into its single bit value. So in the sense, single decimal value, if I consider this is nothing but 0 and this is also 0. So A equals to 0 and B equals to 0. So I am taking the magnitude value. Okay. So A is 0 and B is 0. So obviously A equal to B is supposed to be 1. So any doubt in this?
No, sir.
Okay. So we'll consider the next situation. So I've kept the A input 0 0 itself. I'm changing the value of B. So now if I consider the magnitude of A and B, so the value of A is 0, the value of B is 1. So A is 0, B is 1. So which states that A is less than B. ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? So the output column A less than B will be 1. So any doubt in this? ಅರ್ಥ
No,
ಆಗ್ತಿದೆಯಾ?
sir.
Okay. So we'll consider the next values. So that is 0 0 1 0. So if I consider the magnitude of A and B, so A is 0 and B is 2. So 0 is less than 2. So your column 1 ಆಗುತ್ತೆ. So A less than B column 1 ಆಗಿರುತ್ತೆ. So ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಅಂದರೆ ಯಾವ ರೀತಿ ತಗೋಬೇಕು ಅನ್ನೋದು ನಾನು ಈ ನಿಮಗೆ ಆನಿಮೇಷನ್ ಮುಖಾಂತರ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತಾ ಇರೋಂಥದ್ದು. ಅರ್ಥ ಆಗ್ತಿದೆ ಹೇಳ್ತಿರೋದು? ಓಕೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ನೋಡೋಣ. ನೆಕ್ಸ್ಟ್ ವ್ಯಾಲ್ಯೂಸ್ ನೋಡೋದಾದರೆ ನಾನು ಸೊ 0 ಆ್ಯಂಡ್ 3. ಸೊ ಅಗೈನ್ A is less than B. So the value in the column A less than B will be set to 1. So any doubt in this? So again I will
No,
be
sir.
any doubt in this. So this is the one first case, and in the second case A value is 0 and B value is 1. So we have A less than B set to 1. Similarly, if we go for the third condition, A value is 0 and B value is 2. Again A is less than B, so we have A less than B column set to 1. Next we have the third condition. So A is 0 and B is 3. So with this again we have A less than B column set to 1. So is it clear? ಅರ್ಥ ಆಯ್ತಾ ಟ್ರೂ ಟೇಬಲ್ ಯಾವ ರೀತಿ ಫಿಲ್ ಮಾಡಿರೋದು ಅಂತ?
Yes, sir.
Okay, so if it is clear, now keep on filling the next columns what it is left out. So you have still 12 rows to fill, so keep on filling that 12 rows. So once you have filled the complete truth table, okay, so by this logic, so once you have filled the truth table by employing this, so how this logic works, okay, so your truth table will be like this. Okay, so once we have this output columns filled, so we are going to write that in the shorthand notation form. So summation of, so for A greater than B. So if you look at this, so A greater than B. So in A greater than B, where all 1 is there, so just list out the decimal value. So if you look at the A greater than B, we have 1 at the 4th position, 4, 8, 9, 12, 13, 14. So 4, 8, 9, 12, 13, 14. Likewise, you write it for A equal to B and A less than B. So and you can see that all these were the functions of the input variable A1, A0, B1, B0. So note down fast. Hmm. So after you have finished this writing this shorthand decimal notation, so plot the K map, three K maps for A greater than B, A equal to B, and A less than B. So I will be showing for one. So here this is 0, 0, 0, 1, 1, 1, and 1, 0. So similarly 0, 0, 0, 1, 1, 1, and 1, 0. So again, if we look at cell values, this is 0, 1, 2, 3, 4, 5, 6, 8, 9, 10. So these are the cell values, and now I'm going to consider for okay. So I'm going to plot the K map for okay, A equal to B. So A equal to B ಗೆ ನಾನು K map plot ಮಾಡ್ತಾ ಇದ್ದೀನಿ. So 0, 5, 10, 15. So 0, 5, 10, 15. So what is a possible grouping here? So what is a possible grouping?
Sir, four single ones.
Four single ones. So we cannot able to combine. So the possible grouping is four single ones. So this is the worst case possible grouping what we have. So we cannot able to combine. Okay. So the expression for the first one. So what is the expression for the first? Hmm? So A
One bar,
1 bar, A 0 bar, so B 1 bar, and B 0 bar. So for the second group, fast. So it
B1
is
bar A0, B1 bar B0.
so A1 bar A0, B1 bar B0. Perfect. So likewise, you need to write the expression for all the groups. So like this, you need to plot the K map for A greater than B and A less than B. Fast. So this is the example came up plot for A equal to B. So you need to write all these expressions in SOP form. Okay. And we look at the K map. So for A greater than B, so for A greater than B, we have one quad, two pairs. So A equal to B, we have seen all single ones. And again for A less than B, we have one quad and two pairs. So if we look at the expressions of this, so A greater than B, A equal to B, and A less than B. So note on the equation. ಇಟ ಬರ್ಕೊಂಡಾಯ್ತಾ ಹ್ಮ್
Yes, sir.
Okay, so once you have noted down this, so next is to implement. So this, and this final expressions by using the logic gates or the basic gates. So how the circuit diagram will be, so that we will look now. So this is the complete logic diagram for a two-bit magnitude comparator. No doubt. So any doubt in this two-bit comparator? So any doubt?
No, sir.
So ಅರ್ಥ ಆಗಿದೆಯಾ? So one bit comparator ಮತ್ತೆ two bit comparator ಎರಡು. So most important is the two bit comparator. So with this we will be winding the session. So thank you.